All right, let's go ahead and graph a bunch of these functions. Let's get our brain wrapped around how they move and how the asymptotes move along with the function, how that mother point moves, excuse me, and what happens to the function. So I'm going to go ahead and change into sketch mode here. And we're going to graph f of x equals, let's go 2 to the x minus 1 plus 3. All right? Now, the first thing that you want to identify, and hopefully we beat this into your brain in Algebra 2 and in pre-calculus, is I want to beat into the brain what the mother graph is. And the mother graph is y equals 2 to the x. So I'm just going to sort of do a little dotted line here. Here we go. And there's y equals 2 to the x. But I'm not, just sitting there. The really important thing that I'm trying to deal with here is the fact that my mother point, that I have to acknowledge, is that my mother point is 0, 1, and my horizontal asymptote, smart Alex, is y equals 0. Okay? Now, so let's take that point, let's move it around a little bit, see what happens. I'm going to get this red. Sorry about the dinging. I got to try and figure out how to do that, how to make that stop. So if I look here at x minus 1, so I got 2 to the x minus 1. What does that do to this graph? Well, hopefully by now you realize it moves it to the right one. What does plus 3 do to the function? Well, again, hopefully by now you realize that it moves everything up 1, 2, and 3. So my mother point gets translated up to this point right here. Now, everything else, including this horizontal asymptote, moves with it. That's a really strange thing about the asymptotic behavior with mother functions is even though there are no points, remember an asymptote doesn't have any real points on the graph, it still helps define the graph, and therefore it has to move along with it. So what we end up with is a guy, it looks like that. Okay? Now, how about this one? What if I wanted to do, let's go ahead and I'm going to erase this one. We've already got it. Let's do a crazy one. How's about how about g of x? G of x equals, let's do 1/3 to the x plus 4 minus 1. Again, what we want to be able to do is we want to look at this sucker and go, okay, that's the mother graph. Well, what's the mother graph look like? Well, it still passes through 0, 1. But remember, because this value, 1/3, is between 0 and 1, it's going to look like that. That's the mother graph. This right here is y equals 1/3 the x. Now, I just do exactly the same thing that I did last time. What does x plus 4 do to this mother point, our good friend 0, 1? It moves it to the left 1, 2, 3, 4, right? Correct? And then what's this negative 1 do? Well, because it's outside of the function, it moves in the same direction as its sign. So it's going to move down 1. So my new mother point is going to be over here at -4, 0, which is a little bit weird. The trick here, I'm going to do this in black. The trick here, excuse me, is remembering that this y equals 0, again, the horizontal asymptote moves along with it. So when it shifts down 1, this shifts down with it. And I end up with a function that looks like that. This is, what do we write? G of x equals 1/3 to the x. Wow. Sorry, guys, I'm in my own way. X plus 4 minus 1. Isn't that fun? All right, let me show you one more trick, and then we'll be done with the section. And then when you come to class tomorrow, we'll have a great old time doing some fun, doing some problems together. Okay? All right. How about this one? See if you can figure this one out. Take a minute. Try these. All right. Even though we're going to do a bunch in class, try them. Make sure you give them a shot. How about f of x equals 4 to the 2 minus x plus 3. Okay? Now, hopefully you all see that this, something's screwy, something's goofy. Remember, We're used to seeing things like, you know, f of x equals 4 to the x minus 7, not the other way around. But that doesn't scare us. All that we're going to do is use our negative property. Remember, 7 minus 1 equals negative 1 minus 7. They both equal 6, right? So where's my parenthesis? There it is. So I can rewrite this. I can use this exact same property, basically in general terms, a minus b equals negative b minus a. Right? So I'm going to turn this into a more user-friendly form. I'm going to put it I'm going to write it in a way that's much easier to look at and analyze what's going on. I've got x minus 2, so I flip it, and I'm going to put a negative here. And then, of course, I'm going to do my plus 3. Sorry about that. That's badly written. Let me erase, get a little fine erasing in here. Sorry about that. All right. Oops. So we're going to do 4. Whoa. We're going to do 4 to the, oh, dang it, negative x minus 2. I don't know that I improved that at all. Okay? Now there's lots of ways to look at this now. Again, hopefully this is all review and you're playing with this. But I can look at this a number of ways. For me, this is Ripley's way of looking at this. I see this negative right here. I see that negative out in front as being a y-axis flip. So, whoa, flipped. I don't know what just happened there. So if you think about it, I know if I'm looking at this as y equals 4 to the x as being my, I need a little room down here, y equals 4 to the x as being my mother graph. Okay, well, we're not afraid of that. We've got this, and I need to do some of this. Put some dots on there, right? And then there and there. All right, now, what does that negative do? Well, it's going to flip it across. It's going to flip it across the y-axis. Now, some of you may say, wait, Ripley, that sounds, we've done this before. If this guy right here was y equals 4 to the x, then isn't this guy going to be y equals 1/4 to the x? We just talked about that. Yes, that's exactly what we could have done right here. If I wanted to rewrite this, I could have rewritten this as 1/4 to the x minus 2 plus 3. And then I just apply my stuff. I know that that or that moves this point over 2. I know that that plus 3 moves this up 1, 2, 3. And my new mother point ends up being, what, 2, 4? I think that's 2, 4, isn't it? We have, let's see, 1, 2, up, 1, 2, 3, 4. Yeah, 2, 4. Just like that. And then all I have to do is draw this graph. I'm going to take this mother graph right here. Now, pardon my, remember, don't forget your horizontal asymptote. That horizontal asymptote is along for the ride. So this ends up being my graph. But if you didn't catch that negative right there, remember, had God been a mathematician, the 11th commandment would have been respect thy negative. All right? All right, cool. Hopefully that got you where you need to be as far as graphing exponential functions. And again, just to review, get your brain moving, get you using your calculator to double check your work. We could plug this into our calculator. Might as well do that real quick, right? Have some fun with it. So here you see that I have my different functions that we've been playing with. Like right here, see this guy right there? That's the one that we were just playing with. Now, if I graph this thing, I'm going to go ahead and turn it on. On there. Let's turn it on. Now, whoops. See, I got to toggle back and forth. If I put enter. Now, watch this. Here comes the graph. There's the graph right there over here in the graph box. Let me show you this. Right here is my graph. Just like what we thought. See that? We took 1/4 to the x, which looked like that, and we shifted it to the right 2, up and up 3. Pretty cool. Pretty cool. Well, I hope you enjoyed that. We'll do a bunch of these in class. Again, just to give you some review. And we'll See you tomorrow in class. Hope you enjoy.